I'm sorry, sir. Yeah, good evening. Good evening. In yesterday's class, we saw first and follow sets. The first and follow sets are useful for filling the SLR1 passing table. In SLR1 passing table, for filling reduce actions, we need first and follow sets. For that purpose, in yesterday class, totally we discussed about how to construct the first set for any non-terminal and how to construct the follow set for any non-terminal. We discussed it, sir. So for that purpose, we saw some rules how to construct the first set and how to construct the follow set. So if anyone are having doubt to constructing follow or first set for any, if you are having doubt, please ask me. So I will clear those doubts. Then I will move to the construction of SLR1 passing table. Because without knowing and without without knowing how to construct the first or follow table sets, it is not possible to construct the SLR1 passing table. For that purpose, we must know the how to construct the first set and how to construct the follow set for every non-terminal. That is important, sir. Suppose if you are having doubts or any ambiguity in that, you please ask. First, I will clear those doubts. Then I will move to the how to construct the SLR1 passing table. We saw many problems in yesterday's class. So if you are having doubts in the construction of first and follow set, you please ask, sir. Okay. If you don't have any doubts, we can move to the construction of SLR1 passing table. SLR1 passing table. For constructing SLR1 passing table, so we are having an algorithm. So the algorithm is nothing but the steps involved to solve the given problem. So like for constructing the SLR1 passing table, the algorithm we are following is, in the first step, we are constructing augmented grammar. In the second step, after construction of augmented grammar, we are construct LR0 items DFA with the help of closure and goto functions. These two steps are same as LR0 parsing table. In LR0 parsing table also, first we constructed the augmented grammar for the given grammar. After that, we have constructed LR0 items DFA. So why we are calling LR0 items DFA? Here we are having states. So every state must have exactly one transition with each and every input alphabet. So that's why we are calling that one as DFA. So with the help of closure and goto functions, we are constructing DFA, LR0 items DFA for the given grammar. After the construction in LR0 items, we constructed the parse table by using some algorithm that is nothing but, suppose if it is a terminal, so then we go to shift action. Suppose if it is a non-terminal, we move to the go to action. Sir, this go to is different and this go to is different. So this go to is used to represent the states in a parsing table. Every parsing table, in bottom of parsing, there are two parts. One is the action table. One is action, another one is go to. So For filling up this table, we are using non-terminals. For filling this action table, we are using shift or reduce. So like that. If any production is completed, or finished, then we place with reduce actions. Suppose if it is completed and that is the start state, then we place it with the accept. So these are all things we did for construction of LR0. So in the same manner, here also we need to construct SLR1 parse table. Here also we need to construct the SLR1 parse table. That means fill the table entries with the help of first and follow. So from previous algorithm, LR0 algorithm and SLR1, the only difference is there is no first and follow in LR0, but here we are having first and follow for filling up the table. So we'll see one example, sir. With the example, you can easily check it out. So take some grammar. S derives AB, capital A derives small a, capital B derives small b. So this is the given grammar. For this grammar, we need to construct SLR1 parse table. So first step for constructing parse table, we need to write the augmented grammar for the given grammar. So augmented grammar means adding the new production. So here S dash derives yes. So this, by adding this production to the given grammar, so the grammar will changed as augmented grammar. So S dash derives yes, S derives AB, and A derives small a, B derives small b. So this is the augmented grammar. So first step completed, sir. So in the construction of SLR1 parsing, the first step should be construct the augmented grammar. So construction of augmented grammar completed, sir. Then after that, we need to construct LR0 items DFA. This is the second step. For constructing second step, we are taking augmented grammar. Augmented grammar is S dash derives yes, S derives AB, A derives small a, and B derives small b. So this is the given grammar, sir. So from this augmented grammar, I am using this augmented grammar for constructing LR0 items DFA. Sir, is the total grammar is need to take in LR in I0 or in the first state? So not required, sir. Not required. First we need to take S dash derives dot S, because at the construction of LR0 items, we need to use closure. We need to use go to. So what is the meaning of the closure? Closure means after dot, if we are having a non-terminal, and if that non-terminal is producing any other productions, those productions should be added to this item or this state. So that is the thing. No need to add all these things. So for that purpose, I have taken S dash derives dot S. Here after dot, there is a non-terminal, that is yes, and that is producing S derives AB. So that I am adding dot S derives dot AB. Here, like that, if S is having other productions, those productions also need to add. Suppose more than one production is there, then we need to add all those productions. Okay, good. So here S derives dot AB. Here after dot there is a non-terminal again, and that is producing one more production, that is A derives small a. So A derives dot small a. Here it is a terminal, so no need to add any other productions from A. So from A. So that's why it is completed. It is completed, and it is the state I0 or item. So we are giving the name as I0. We are giving the name as I0. Sir, what about B derives, capital B derives B? So present it is not required. Present not required in I0. So suppose if it is required, then we will add. So we will see. After that, closure is completed, sir. Now closure is completed. Closure means if any production is in the form of dot S and S is deriving other productions, we need to add those production to this item. That is the closure. Go to means moving the dot symbol towards right. Moving the dot symbol towards right. Suppose if we take this production, we can write it as, after that we are having S. So S dash derives S dot. Here with this production, we have completed go to action. Go to. So here it is closure completed. After that, go to completed for this production. After that, take this one. Here S derives A dot B. A dot B. For this production also, it is go to is completed. And take another production is there, that is A derives small a dot. For all these three, go to completed. Again, we need to check, is there any possibility of closure for every production? Is there any possibility for closure here? No, sir. Because so dot, it is after dot we don't have any non-terminals. After dot we don't have any non-terminals. So we cannot extend this one. Suppose if you see here, after dot there is a non-terminal, that is B. After dot there is a non-terminal, that is B, and that B is producing some other. So we need to add B derives dot B to this item, sir. To this item. Is there any other? No, sir. Because only one production is available with B, and here we got one more production. After dot there is no non-terminal. So if that is a non-terminal, so that should that don't expand or produce any other productions. So no need to add any other. So this is the thing. After that, we move to A derives small a dot. Here it is completed because after that there is no non-terminal, sir. There is no non-terminal. So this is I1, I2, I3. So these are the only names, sir. We can give our own. We can start with I1, I2, I3, I4 also. So initially we are starting with the I0 because in textbooks, most of the textbooks and most of the examples, it starts with I0. That's why I'm starting with I0. Suppose if you want to start with any other number, you can start it, sir. You can start it. It is not a problem. So next, those are the state names only. So it is completed, and come to here, it is not completed. So by performing go to action on this one, S derives AB dot, sir. S derives AB dot. So here it is also finished. So there is no non-terminals after dot. So no need to add any other productions to this one. And that means closure is not possible here. Closure is not possible here. So come to here, B is deriving, capital B is deriving B. So that is B dot. So here also it is also completed. So dot came to end with this production, with this state, with this state, with this state. So our task completed. This is I4, sir. This is I5, sir. So how many states are there, sir, totally? 5 or 6? So you may get the question. After constructing the LR0 items or LR1 items, so in the examination, they may ask question. So that question may be, how many number of states are there after constructing the LR0 items DFA? So most of us may do some mistake, that is 5 states, because we end with 5. We end with 5. So totally 5 items are there. That means 5 states are there. But that is wrong, sir. What is the wrong? So here we start with 0. State 1, 2, 3, 4, 5, 6. Totally 6 states are there. Totally 6 states are there. So if you get the question, how many number of states, you please count clearly. Then only you can give the correct answer. Suppose if you see last state, you may give the wrong answer. So for that purpose, before going to answer questions to count the number of states, then you please try to count the total number of states, because if you give the wrong state number, so if you consider the last state, that may leads to the negative marking, and that maybe leads to the wrong answer. So that's why my suggestion is, you please count the total number of states before going to answer this kind of questions, because most of us may do mistakes or to choose wrong answers in these situations. For that purpose, I am removing. Okay, so first step is completed. Augmented grammar completed, and construction of LR0 items. Construction of LR0 items is also completed. So third step is filling up the table. So for filling up the table, first we need to draw the table. In the bottom of parsing, so our parse table contains two parts. So one part is action part, another part is go-to part. In the action part, we have terminals. So what are the terminals in the given problem? So here the terminals are A, B, sir. A and B. So A, B, and along with the AB, we use the dollar symbol for acceptancy. We use the symbol that is dollar for acceptancy. And in go to, we need to fill up with the non-terminals. We are having non-terminals, capital S, capital A, capital B. So in the given grammar, all the non-terminals are represented with capital letters, and all the terminals are represented with the small case letters or special symbols. So that is very important, sir. So here now we need to fill this table, sir. To fill this table, first you check how many number of states are there. So I0 to I5. So take I0 to I0, I1, I2, I3, I4, I5. Okay. Yes, sir. We need to fill this table now. for filling up this table. So that is almost everything is same like as LR0 items table only, sir. LR0 table only, sir. So in LR0 table, so we checked. Here I am at I0. Here I am at I0. By getting S, capital S, I am moving to I1. Here I am at I0, state is I0. By getting capital S, I am moving to I1. That means I0 on yes. So that is I0 on yes, that is 1, sir. That is 1. I am moving to the state 1. I am moving to the state 1. So after that, here I am at I0. After A or getting A, I am moving to I2. I am moving to I2. So that means I0 on A moving to the state 2. State 2. And here I0 on small a. I0 on small a. Suppose if it is a capital letter, that is a non-terminal. Small letter, that is a terminal. So if it is a terminal, we need to write S3. That means shift 3. S3 means shift 3. So that's why I need to write I0 on small a. I0 on small a, that is S3. I0 on small a, that is S3, sir. So here with I0, I have completed 3. So coming to the I1, so this is ended. So you please wait. So coming to the I2 on capital B. I2 on capital B. I am moving to I4. I2 on capital B. I2 on capital B. I2 on capital B. I am moving to state 4. I am moving to state 4, sir. This is 1. This is 2. And this is 4. This is 4. This is S3. This is S3. So here, after B, one more is there, that is small b. I2 on small b moving to I5. So here it is a terminal. So we need to write S5. We need to write S5. I2 on B. I2 on B, that is S5, sir. That is S5. And next, it is completed. It is also completed. And coming to here, it is ended. So you please wait. So for the ending productions, you please wait. And here it is also ended. And here also it is ended. Suppose if the production is ended with the dot symbol, those are considered as reduces or acceptancy. Those are considered as reduced actions or acceptancy. Here S dash derives S dot. Because S dash is the start symbol and it is ended, we can say that that is accept. That is accept. So we need to write I1 on dollar. I1 on dollar. So that is accept. So for that purpose, I1 at dollar, we can write it as accept. Sir, how can you writing? It is accept because this is the start state. S dash is the start state. We have considered at the time of writing augmented grammar. At the time of writing augmented grammar. That's why I have filled that cell with accept. That cell with accept. And this is the production. This is the production. And this is also the production. This is the production we added to the given grammar. But this is the production is given in the grammar. It is also given in the grammar. It is also given in the grammar. So we need to reduce these three. We need to reduce these three. So this is the important thing, sir. Up to now, this is everything is same like as LR0 parsing table. Up to now, I have discussed the same thing what we did in the LR0 parsing table. So this is the new point we need to add to the LR0 parsing table. So that is reduction. At the time of reducing, first we need to check if the grammar is in the format of like, looks like a derives small a dot. Here it came to end of the production on the right hand side. So then we need to check follow of a. Then we need to check follow of a. For this kind of production, we need to check follow of a. Suppose if you see here, a derives small a dot. Here we need to check follow of a. So how to check the follow of a? How can we check the follow of a? So first thing we need to do, writing the follow and first for the given grammar. A derives small a and b derives small b. So this is the given grammar. For writing first S A B. So first of yes, that is nothing but first of a. First of a means a. So first of a, that is a. First of b, that is b, sir. What about follow? So follow of S. S is the start symbol. So we add dollar to the follow of S. We add dollar for the follow of S. After that, we need to check the follow of A and B. Here there is no capital A or capital B. Here there is no capital A, capital B in the right hand side. So we no need to consider these two productions. We need to consider this production only. From this production, follow of A, that is there is a B, and is there B is producing epsilon? No, sir. So for that purpose, what we can write? Follow of A equals to first of B. What is the first of B here? B, sir. So follow of A means B. Sir. Same, in the same manner, we need to consider S derives AB, follow of B. After B, there is no symbol. So in that case, we need to write follow of B equals to follow of yes. What is the follow of yes here? Dollar. So that is dollars. So for that purpose, follow of yes is dollar and follow of A is B and follow of B is dollar. So what I am saying is, here we need to reduce this production. This production is in the form of A derives small a. If any production is in the format of A derives B dot, like we need to check the follow of the left hand side non-terminal. For reducing this production, we need to check the follow of left hand side non-terminal. Here follow of A. What is the follow of A here? B, sir. In that place, we need to write reduce. Before reducing, we need to give the numbering for that. So for that purpose, this is 1, this is 2, this is 3. So A derives small a, that is second production. So for that purpose, we need to give R2. So at I3 with B, At I3 with B, we are placing, at I3 with B, we are placing R2. At I3 with B, we are placing R2. Why, sir? Because A derives small a dot. Here we are finding the fall of A. Fall of A means B. So we are at I3. So at I3 comma B equals to R2. Equals to R2. I3 comma B equals to R2. In the same manner, if you see, it is also need to reduce. Here S derives AB dot. It is finished. We don't want to consider about right hand side part. We just consider left hand side non-terminal. What is the left hand side non-terminal? Yes. And where we are? We are at I4. I4 comma follow of yes. What is the follow of yes? Dollar. I4 comma dollar equals to R1 because S derives AB is the first production. Because S derives AB is the first production. I4 on dollar, that is R1. In the same manner, P derives small b dot. We are at I5. We are at I5. So what is the fall of B? Fall of B is equals to dollar. So I5 on dollar, that is R3. That is R3. So this is the way for constructing SLR1 parse table. This is the way for constructing SLR1 parse table. Before constructing the SLR1 parse table, so up to construction of LR0 items DFA, it is same like as LR0 parsing table. At the time of filling the table only, we need first and follow. First and follow. It is also very easy, sir. We are having some 3 or 4 rules for first and follow. So by using those rules, you can easily write the first and follow for every non-terminal. By using those first and follow, we can fill the reduce actions. We can fill the reduce actions. Sir, what is the difference between LR0 and SLR1? So suppose if it is LR0, so what we will do? We fill R2, R2, R2. Every terminal is filled with reduce symbol. And here it is R1, R1, R1. Here it is R3, R3, R3. So with LR0, so 9 reduce actions are there. But with the SLR1, only 3 reduce actions are there. So that is the drawback with LR0. That is the drawback with LR0. In LR0, we are getting more number of reduce actions. More number of reduce actions. So that is the one drawback. And compared to powers, it is less powerful than SLR1. Sir, how can you say the powerful or the power of LR0 and SLR1? The algorithm which accepts more grammars, the algorithm which accepts more grammar is more powerful. So here SLR1 accepts more grammars than LR0 parsing. So that's why SLR1 is more powerful than LR0 parsing algorithm, or LR0 parsing algorithm is less powerful than SLR1. So these two are the drawbacks of LR0. One is more number of reduce actions. In the previous examples, if you see, with the LR0, there are 9 number of reduce actions. There are some unnecessary reduce actions are there here. But coming to the SLR1, here it is having only 3 reduced actions. It is only having 3 reduced actions. Compared to SLR0 algorithm, it is having less number of reduced actions. That's why SLR1 is more powerful than LR0 parsing algorithm, as well as it is having less number of reduced actions. Less number of reduced actions compared to LR0 parsing algorithm. That's why we can say that SLR1 is more powerful than LR0. LR0. So this is the thing, sir, for constructing SLR1 parsing table. For constructing the SLR parsing table, first we need to construct the augmented grammar. After that, we need to construct the LR0 items for DFA. LR0 items DFA with the help of closure and goto. After that, we need to construct the parsing table. That means we need to fill the entries of the parse table or SLR1 parse table with the help of first and follow. For finding the first, we are having some rules. For finding the follow, we are having some rules. So by using those rules, we can construct the first and follow for every non-terminal. With the help of that first and follow, we can fill the reduce actions of the parse table. Reduce actions of the parse table. So this is the thing, sir, for constructing the parse table. So we'll check one more. Right, sir. So in the examination, they may ask the questions like this, sir. So for constructing the parsing table only, we can answer these questions. So without constructing a parsing table also, we can answer, sir. With the help of DFA itself, we can answer. With the help of DFA, we can answer. So here, how many reduce actions are there, sir? 1, 2, 3, sir. 1, 2, 3, sir. Suppose follow of yes, for example, in some cases, the follow of yes is $, So how many reduce actions are there, sir? 4, because with $, 1 reduce action, with small a, 1 reduce action, with B, 1 reduce action, with $, 1 more reduce. So totally 4. Suppose if it is not there, so that is 3, sir. Suppose A, B, $. So how many, sir? 1, 2, 3, 4, 5, sir. So like that, we need to construct, we need to check. So by knowing how to constructing the follow first and by constructing the LR0 items DFA, we can easily specify or we can easily tell how many number of reduce actions, how many number of shift actions, and how many number of go to actions. So please write down, sir. How many reduce actions in SLR1 parsing table for the grammar E derives T plus E derives T and T derives A. So for constructing DFA, we can specify. Without constructing DFA of LR0 items, we cannot specify. For that purpose, before going to constructing the DFA of LR0 items, first we need to construct augmented grammar. E derives E derives T plus E, and E derives T derives small a. So this is the augmented grammar. With this augmented grammar, what we can construct? We can construct LR0 items DFA. So for constructing LR0 items DFA, we are using closure and goto functions. Suppose first thing is E dash derives dot E. Here, after dot, we are having non-terminal symbol. So we need to check, is this non-terminal symbol is producing any other symbols or any other productions. So here E is producing these two productions. So we need to add these two productions. E is deriving T plus E dot T plus E, and E is deriving dot T. So with this, we need to add these two, sir. So I already, in the starting example also, I already mentioned, if any non-terminal is producing more than one productions, we need to add all those productions to this item, So that's why I am added. So I added E derives dot T plus E and E derives dot T, sir, dot T. So here, after dot, we are having again non-terminal, that is T. With this we are having, with this we are having. So after dot, that is T only. That's why we can add that production once it is sufficient. So for the purpose, what is the T production? T derives small a. So that's why T derives dot a. T derives dot a. So this is I naught. This is I naught. So from this, I am writing E dash derives E dash derives E dot. E dash derives E dot. And coming to here, E dash derives T dot plus E. E dot derives T dot plus E, and E derives T dot, because I naught on T, sir. So why I am adding these two in the same item, because I am at I naught, state I naught with the input symbol capital T. It is not required to write separate states, because that is the same symbol. So with the same symbol, we move to the only one state only, sir. Only one state. So that's why I added these two. Here, after dot, there is a terminal. So no need to add any other productions. And here, after dot, there is no non-terminal or any other. So it is also completed, sir. Coming to here, T derives A dot. So it is ended with the dot. It is also ended with the dot. Only one production is there, that is E derives T plus dot E. If you see here, after dot there is a non-terminal again. So we need to add all the productions which are produced by the E. That's why E is producing dot T plus E, and E is producing dot T, sir. E is producing dot T. Again, here we are getting T. That's why T is producing dot A. sir. So that's why we need to expanded the closure. After closure, we got this state, sir. This state with these entries. So suppose if you see here, this is again the separator. That is E derives T plus E dot. Because after that we are getting E. After that we are getting E. We are moved to separate. And suppose if you see here, these two are same. These two are same as these. E derives dot T plus E, and this is dot E derives dot T. So these two are need to move this state. These two are need to move this state, because here these two are same, sir. These two are same, sir. So by getting dot T, we are moving to this one. Here also after dot T, we need to move to this state, sir. And after that, T derives dot A. So that is need to move to this one. So these are the things. Here, if you see how many number of reduced actions are there. So first of all, how many number of states are there, sir? I0, I1, I2, I3, I4, I5. So total number of states equals to 6, not 5, sir. 6, it's 6. It ends with the 5, but we are started at 0. That's why it is 6. Don't forget that. So after that, what he is asking, how many number of reduced actions are there? How many number of reduced actions are there? So suppose reduced actions means here it is reducing, and here it is reducing, and here it is reducing. So what we need to do? First of all, we need to write I2 at I2 is deriving T dot. For that purpose, first of all, we need to find the follow for E, follow for E, follow for T, follow E, and follow for T, sir. Follow E and follow for T. So here we are having only T, E. So for that purpose, follow E and follow T we need to find. What is the follow of E? What is the follow of E here? Here, A is nothing but 1 minute, sir. Suppose if we see here, first and follow. So first of E, first of T. First of E means first of E means T, because it is not required. For this, we need to write first and follow, sir. So suppose, because if you see the dots, so you may get some confusion. For that purpose, I am writing again first and follow E and T, because only two non-terminals are there. Because two non-terminals are there. Here, first of E means T. First of T means small a. First of T means small a. First of T means small a. And suppose here first of T means again small a. First of T means again small a. And suppose for E we are having this one and this one. So first of T, that is small a. First of T means only this one we are having. So from that we can write a, sir. Right. Next, follow of follow of E. Here E is the start symbol. So for that purpose, we need to add dollar. For the purpose, we need to add dollar. For the purpose, we need to add dollar. And coming to here, follow of T. So what is the follow of T? There is a plus symbol. There is a plus symbol. So follow of T plus symbol is there. And from here, fall of T is equals to fall of E, sir. Fall of T is equals to fall of E. Because after T, there is no terminal or there is no non-terminal. That is the end symbol. So that's why fall of T is equals to fall of E. That means fall of E means dollar. Fall of E means dollar. Fall of E means dollar, sir. So if you check, here we need to reduce this one, and this one. For reducing E, we are having 1. And for reducing E, we are having fall of E is equals to dollar. So for that purpose, one time. Coming to here, for reducing T derives small a, we are having 2 look ahead symbols. So that's why 2 reduce actions are required. Where it is required at plus symbol and at dollar symbol for particular states. That's why 2 reduce actions are required. So finally, 4 number of reduce actions are there. So in the given question, he's asking how many reduce actions in SLR1 passing table for the given grammar. So for that purpose, first we have constructed the augmented grammar. From that augmented grammar, we have constructed the LR0 items DFA. With LR0 items DFA, we have constructed some states. In these states, this is a reduction. Here, T is reducing. Where the T is reducing at 2 places. Where those places? This one, plus and dollar. So for the purpose, T is reducing at plus and dollar. I3 on plus. This is the third production. So we need to write R3. Again, I3 on dollar. We need to write R3, sir. For this production, so we need to write, this is the second production. I2 on dollar, because in the follow fall of E is equals to dollar. I2 on dollar equals to R2, and here it is I5 on dollar equals to R1. So finally 1, 2, and here 2. That is at one place dollar, another place is at plus. So for the purpose, 2, 1, 3, 2 plus 1, 3, 3 plus 1, 4. So finally, how many reduce actions are there? 4 reduce actions are there. 4 reduce actions are there, sir. 4 reduce actions are there. How many number of go-to actions are there? Sir, how can we find the go-to action, sir? Suppose this is the go-to action, because capital A, capital T, and small a. So these two are go-to actions. And this is plus. And here it is capital E. And here it is capital E, sir. So how many number of go-to actions are there, sir? 1, 2, 3, and 4. 4 go-to actions are there. How many number of shift actions are there? 1, 2, and 3 on A. So If it is a terminal, that is the shift action. If it is the non-terminal, that is the go-to action. If the production is ended with dot, that is the reduce action. If the production is ended with dot, that is the reduce action. If it is non-terminal, that is the go-to action. If it is the terminal, that is the shift action. So you may get the questions like how many number of go-to actions are there and how many number of shift actions are there, like that, sir. So for that purpose, you need to check how many number of terminals are there, how many number of non-terminals are there, or how many number of states are constructed with the terminals or non-terminals, like. And for reducing actions, you need to check the first and follow. You need to check the first and follow for the given grammar. With the help of follow only, we can say the particular number of reduce actions. The particular number of reduce actions. So this is the way for constructing the SLR1 parsing table and for finding the number of shift actions with SLR1, number of reduce actions with SLR1, sir. Sir, shift actions, there is no change. Shift actions, there is no change. And go-to actions also, there is no change. For LR0 and SLR1, suppose if you take LR01 parsing algorithm and SLR1 parsing algorithm, shift actions, no change. Here also shift actions, no change. Shift actions are same in LR0 and SLR1. And go-to also same. Go-to actions also same. But the change is with the reduce actions. With reduce actions, there is a change. That's why they may ask a question like as how many number of reduce actions, because there may be a chance of change of reduce actions. There is a previously asked question, it's there, sir, with this kind of explanation. If you see that, which of the following is false? Which of the following is false in comparison of LR0 and SLR1 parsing table. So here we are doing comparison on LR0 and SLR1. So I already told you only the difference is at the reduce actions. So the shift actions are same and the go-to actions also same. So I already informed you. So here is the previously asked question, sir. Which of the following is false? Which of the following is false? Sir, before answer the gate question, every time read the question twice, because so sometimes our intention is different and the intention of the question is different. Here we need to check the false condition, not the correct true. Here we need to consider the false. So okay, the options are number of shift and go to, not this go to, sorry, number of shift and go to actions, same actions, same in both tables. Number of shift actions, same in both tables. Sorry, sir. First option is that is only. Second one, number of go to actions, same in both tables. And third one is number of reduce actions. Number of reduce actions may be different. May be different in both tables. In both tables. And coming to the last option, number of errors or number of error actions. Number of error actions same. Number of error actions same in both tables. In both tables. So, which option is correct, sir? Which of the following is false in comparison of LR0 and SLR1 parsing table? By comparing LR0 parsing table and SLR1 parsing table, so which option is wrong? Which option is wrong? First option, he is saying shift actions in both tables are same, and go to actions in both tables are same, and reduce actions may be different. So that is one. And next one is number of error actions same in both tables. Number of error actions are same in both tables. Can anyone please answer this question? Which option is correct, sir? So number of shift and number of shift actions are no change. Number of go to, sorry, this is not a small case, sir. This is capital letters, right? I need to use capital letters because this go to is different and this go to is different. So this go to is an action, this go to is an function. So this is belongs to table and this is belongs to for finding the LR0 items. So okay, good. So there is no change in shift actions and there is no change in go to actions. Both are same. And in the option itself, he mentioned the number of reduced actions may be different. Yes, the reduced actions may change. That's why there may be a chance of different. So another last option is number of error actions are same in both tables. Sir, when we say that is an error action, when we say that is an error action, all the empty column, all the empty cells are error actions. We mentioned earlier all the empty cells. Suppose if it is a LR0, this is not empty, 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 this is not empty. So, but in SLR1, this is empty, 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 this is empty. So in the same manner, if you see here, all the empty cells are same, other than the reduce actions, If LR0 items or LR0 parsing table having more number of reduce actions than SLR1, so the number of error actions are not equal. So, but in the question, he is giving the option as the number of error actions are same in both tables. So this is not correct, sir. This is not correct. So that's why option D is the correct option for the given question. So in the case of false case, sir. So right. So here up to now we saw how to construct SLR1 parse table and how to find the number of reduce actions with the SLR1 parse table and how many number of go-to actions, and how many number of shift actions, and how many number of states also. These 4 different kind of questions you may get in gate examination, sir. Suppose if you are having any doubt or ambiguity or any questions, you can please ask up to now. Sir, if anyone are having doubts, you can ask. Okay, sir, good. So next one is detecting the grammar is SLR1 grammar or not. Up to now, we know, or we can find the given grammar is ambiguous grammar or not, ambiguous grammar or not, or ambiguous grammar or unambiguous grammar, unambiguous grammar. And the same way we saw is the given grammar is LR0 grammar, LR0 grammar or not, LR0 grammar or not. Suppose if there is a reduce conflict or shift reduce conflict, that is not the LR0 grammar. Otherwise, that is the LR0 grammar. So we discussed so many number of problems in previous classes about LR0 grammar. So now our task is the given grammar is SLR1 grammar or not? Is the given grammar is SLR1 grammar or not? Sir, how can we say the given grammar is SLR1 grammar? How can you say the given grammar is SLR1 grammar or not? Sir, for any grammar is in the format of S derives alpha dot small a x and B derives y dot. Here it is shift action and here it is reduce action. That means shift reduce. This is the problem with the LR0. This is the problem with the LR0. If any grammar is in the format of, or any state or any production is in the format of alpha dot ax or B derives y dot, in this format, we can say that that is not a LR0 grammar. That is not a LR0 grammar. So this is a one thing. Another one is A derives x dot, B derives y dot. So we can call this one as reduce. We can call this one as reduce. With this type of productions also, we can say that that is not a LR0 grammar. With this, we can say that that is not the LR0 grammar. But is it SLR1 or not? How can we say, sir? First thing, suppose if it is, if the grammar is in this format, this is the first point we need to consider. And after that, we need to check. Here I am shifting small a and I am reducing capital B. Suppose follow of B contains small a, then that is not a SLR1 grammar. So first it needs to be shift reduce conflict. It has to exist. After existing shift reduce, we need to check if the reduce action production, in the reduce action production, left hand side non-terminal follow we need to consider. So here the follow of B, here if the follow of B contains this terminal, if the terminal which is shifting is the symbol of fall of B, then the given grammar is not an SLR1 grammar. Then the given grammar is not an SLR1 grammar. So once again, I'm explaining you, sir. So suppose if you take a shift reduce conflict, the grammar is in the format of A derives alpha dot small a x. Sir, only after dot, if there is a terminal only, we can call that one as a shift. Otherwise, that is not the shift action. So, and along with this production, in that item, if there is another production that is reducing, that is called as shift reduce conflict. In that case, we need to check one more condition. The condition is follow of B contains that terminal. What is we are going to shift? That terminal contains in the fall of B. Then that grammar is not an SLR1 grammar. Otherwise, that is a SLR1 grammar. So that's why what I'm going to say is, first we need to check, is there any shift reduce conflict or reduce conflict? If there is a shift reduce conflict, so in the reduce production, the non-terminal contains the terminal which is we are going to shift. If it contains, then that is not an SLR1. Otherwise, that is SLR1. In another case, there is a reduce. Now here we need to consider fall of A and our instruction, fall of A instruction, fall of B. That should be equals to pi. That means the entries of fall of A and the entries of fall of B should be null or should be 0. So same entry or same terminal should not be exist in fall of A and fall of B. Then we can say that is SLR1 person. Otherwise, if any terminal exists in both, then that is not SLR1 grammar. So for checking the SLR1 grammar or not, we need to check, is there any shift reduce or reduce at the time of constructing LR0 items DFA. If there is a shift reduce, then we need to check one more condition, that is fall of B contains that terminal. What is the shifting terminal? If it contains, that is not SLR1. And suppose if it contains reduce, if it contains reduce, at that time the fall of A and fall of B are fall of A intersection fall of B. If you perform this action or this operation, we will get pi. If you get pi, that means there is no common symbols. If there is no common symbols, we can say that SLR1 grammar. Or if any terminal or if any symbol, if any common symbol is there in fall of A and fall of B, then we can say that is not the SLR1 grammar. Sir, to check the given grammar is SLR1 or not, we need the knowledge of writing the LR0 items DFA. Along with that, we need knowledge of shift reduce and reduce. Along with that, fall of B contains that terminal or not at the time of shift reduce, and reduce fall of A and fall of B should not contain the same symbol. With this knowledge, we can say, or we can answer for the questions given with the SLR1 grammar or not. or not. So, okay, sir, we'll check the one example. Suppose E dash derives dot E derives dot T plus E, and E derives, sorry, E derives dot T and T derives dot A. T derives dot A. Suppose if this is the given grammar, the same example I explained you how to construct the LR0 items. So okay. So from this, with go to action, E derives E dot. E derives E dot. So before going to another state, first you check here. Is there any shift and reduce actions? Both shift and reduce, or reduce. So this is not a shift action. This is not a shift action. This is not a shift action. This is the only shift action here we are having. So there is no problem. That's why we are moving to another. So here it is completed. Then coming to here, if you are coming to here, E is deriving T dot plus E, and T is deriving, sorry, again E is deriving T dot. If you see here, this is the reduce action and this is the shift action. Sir, how can you say? Because after dot there is a terminal and this production ended with dot. So that's why I can say that there is a shift and reduce actions are there in the same item. Then if any item having shift reduce, then we need to check follow of B contains the shift symbol. So for that purpose, we need to construct fall of E. Suppose if you see here, what is the fall of E? Fall of E is the start symbol. So fall of E is dollar. After that, here there is no E in the right hand side. Other than here, there is no E in the right hand side. So only the fall of E is only dollar, sir. Only dollar. So is fall of E contains plus. We can say that is not a SLR1, but plus is not in fall of E. So we can say that here this is not the problem. To tell it is not an SLR1. Grammar. So that's why I am moving to forward. So here it is T derives A dot. Then here by moving to plus, I can write E derives T plus dot E. Here it is E. So E means E is deriving this one, and E is deriving dot T, and T is deriving dot A. So this is the go to, and this is also go to. This is a shift. So here also there is no problem, sir. With this I can move to here, and with this is same as this one. So I am moving to here, and from this I can write, E derives T plus E dot. So in the given grammar, we are having shift reduce conflict, but fall of E does not contain the shift symbol, that is plus. So that we can say that the given grammar is SLR1 grammar. So that we can say that the given grammar is SLR1 grammar. So first we need to construct the LR0 items of DFA. At the time of constructing SLR0 items of DFA, we need to check, is there any item having the shift reduce conflict or reduce conflict. If it contains a shift reduce conflict, we need to check in the reduce production, the left hand side non-terminal. For finding the follow for this, that should not contain the symbol which is in the shift action, So then we can say that is the SLR1 grammar. Or suppose if you take a reduce type, so reduce of fall off, for reducing we are having two productions at there. Suppose if you take A and B, fall of A and fall of B should not contain the same symbol, So if it contains the same symbol, we can say that is not an SLR1 grammar. Suppose if it does not contain the same symbol, we can say that is the SLR1 grammar. This is the way for finding or checking the given grammar is SLR1 grammar or not. So take one more example, sir. S derives capital A and S derives small a and A derives small a. By writing augmented grammar, we can get S dash derives S derives A, S derives small a, and A derives small a. From this, S dash derives dot S. Here it is a non-terminal. So S derives dot A and S derives A. So S is deriving two more productions. And after that we are having capital A. So that's why A derives dot A. So all are go to and shift actions. So there is no problem. So next, coming to here, S dash derives S dot. So okay, no problem. So it is ended with dot. Suppose if you see here, S derives A dot. So here also there is no problem because it is also ended. If you see here, on small a, S derives A dot and A derives A dot. Sir, see here. I am at I naught with the state by reading input symbol small a. Both are same. No need to consider the left hand side symbol. After dot symbol only we consider. So after dot here we are having small a. That's why small I naught on small a. So this production is moving to I naught, I1, I2, I3, state I3 or item I3. So and here it is also after that there is a small a. So it is also moving to same one, sir. Suppose if you see here, it is reducing and it is also reducing. It is reducing and it is also reducing. So in that case, we need to check fall of S and fall of A. Fall of S and fall of A. Suppose if you see fall of S, here S is the start symbol. So fall of S. So S and A. Fall of S is equals to $. Fall of S is equals to dollar. Here on the right hand side, we don't have any non-terminals. So for finding the follow, we consider only right hand side. So for the purpose, we no need to consider these two. For finding fall of A, there is no symbol after A. So for the purpose, fall of A is equals to fall of S. In that case, fall of S is dollar. So fall of A is also dollar. So dollar is existed in the fall of S as well as dollar is existed in the fall of A. Dollar is existed in the fall of S and dollar is existed in the fall of A. So that is equals to not equals to pi because that is equivalent to dollar. The common symbol is dollar. If the fall of A and fall of B, the common symbol existed, then we can say that grammar is not an SLR1, not an SLR1 grammar, not an SLR1 grammar. So that grammar is not an SLR grammar. So the given grammar is not SLR1 grammar, not SLR1 grammar. So for finding the SLR1 grammar or not, or for checking the given grammar is SLR1 grammar or not, so we need to construct LR0 items. After that, if it any item having a shift reduce or reduce shift reduce or reduce conflict, then there is again we need to check some more condition. If that condition satisfies, then we can say that is not an SLR1 grammar. Otherwise, that is an SLR grammar, sir. So this is the thing, sir. So we'll check one more example, sir. We'll check one more example. So need more number of problems. You need to practice more number of problems is required, sir, to answer these kind of questions. S derives capital A, small a, and S derives capital B, small b, and A derives small d, and B derives small d. So this is the given grammar, sir. For this given grammar, for the augmented grammar is S derives A, S derives B, A derives small d, B derives small d. This is the augmented grammar. For that, if you write SLR10, right, SLR0 items, S dash derives dot S, S derives dot AA, and S derives dot BB, and A is deriving dot D, and B is deriving dot D, because here A is there, here B is there. So with the A productions, we are writing, with B productions, we are writing. So that is the thing, sir. So after that, if we see here, so it is S dash derives S dot. So no problem. Here it is S derives A dot small a. So only A, we are having one production. So we cannot add more productions because after that there is no non-terminal. So with this S derives capital B dot small b. Here also the same. If you see here, A I naught on D, I naught on D. So A D dot, B D dot. Here coming to the LR0, we can say that it is not an LR0 grammar because it is not, it is having reduce problem. It is having reduce problem. For specifying LR0 grammar, it is containing reduce or shift reduce problem is sufficient. But for specifying SLR1 along with reduce, we need to check, is there any common element of follow of A and follow of B? So for that purpose, first we need to write the follow of S, A, B, sir. S, A, B. So suppose if you see here, follow of S is dollar, sir. Initially follow of A is dollar, sir. Fall of S is dollar, sorry. Fall of A is small a, and fall of B is small b, because after B we are having small case letter, that is terminal. After A we are having small case letter, that is small a. So already we are having a production. A derives alpha bx, and x does not belongs to epsilon. X does not belongs to epsilon. Directly or indirectly, we can say that fall of B is equals to first of X. Fall of B is equals to first of X. First of X means here it is a terminal. So if any terminal is first of, if any terminal is that terminal only, sir. So for the purpose, fall of A is equals to small a, fall of B is equals to small b. So fall of B is equals to small b, sir. So that is the thing. From these two, we cannot write a follow because there is no non-terminal on the right hand side. So okay, it is completed. Fall of A contains small a, fall of B contains small b. So both are equivalent? No. So that's why this is equivalent to pi. So we can say that this is SLR1 grammar. So the given grammar is SLR1 grammar. So the given grammar is SLR1 grammar. Even though there is a reduce conflict, the fall of A and fall of B does not having the same symbol in their follow sets. So we can say that that is the SLR1 grammar. That is the SLR1 grammar. So this is the way, sir, for constructing the given grammar is SLR1 grammar or not, like SLR1 grammar or not. Right, sir. Previously asked 2 marks question, sir. This is a previously asked GATE 2 marks question. Which of the following is, so before going to this one, we'll do one more problem, sir. Wait. Check the given grammar is SLR1 grammar or not. S derives capital A, and A derives AB, A derives epsilon, B derives small a b, and B derives small b, sir. So for this, by writing augmented grammar, we can write it as S derives S, S dash derives S, S derives A, and A derives AB, and A derives epsilon, and B derives AB, B derives small b. For constructing LR0 items of DFA, we are starting with S dash derives dot S, and S is deriving A, and A is deriving AB, and A is also deriving epsilon. Sir, previously at the time of checking the given grammar is LR0 grammar or not, I discussed if any production with epsilon, so at that time we write epsilon dot, but we don't write dot epsilon. So that is without reading any symbol itself acceptance, because this is an empty string. Epsilon is empty string. So that's why without reading any symbol itself, we can say that that is accepted. If simply we can say that in formal language and automata theory, sometimes the first state or the start state itself, the final state, the start state itself, that is the final state. So in those cases, we may get this kind of productions, without reading any symbol. We can say that start state itself, the final state, epsilon is accepted. So for that purpose, we are using this kind of productions. So hope you got the point. If you are having any production with A derives epsilon, so you need to write like A derives epsilon dot directly, Here, if you see, no need to add B productions, because after dot there is no B. After that there is no B. So here it is ended. Suppose if you see here, this is the go-to, this is the go-to, this is the go-to, and this is the reduction, but to specify the conflict, we need shift reduce or reduce. We need shift reduce or reduce. Here we are having only one reduce. Sir, after dot, if there is a terminal, then only we can say that is the shift action. After dot, if we are having non-terminal, that is not the shift action, that is the go-to action. Okay, good. So here, if you expand S derives, if you write a go-to items, S dot. So, and here S derives A dot, and here S derives A dot, and S derives A dot. Sir, here we are having two productions because we don't see S. Here we see after the symbol dot. So after the symbol dot, we are having A, sir. So the symbol is A. For that purpose, we need to add A derives A dot B. A derives A dot B. Here after D, after B, there is, sorry sir, here after dot, there is a non-terminal. That's why we need to add terminal B productions. The B productions are dot AB and B production, one more B production is this. Suppose if you see here, there is a reduction. If you see here, there is a reduction and there is a shift. And there is a shift. Here A is shifting and B is also shifting. So for that purpose, we need to check what is the follow of S. Here S is only the start symbol. It is not existed on the right hand side. So follow of S is dollar. Dollar is not the symbol of A and B. So we can say that the follow of S does not contain A or B, because A and B are the shift symbols here. So that's why it is not the problem here. So we can forward. It is not the problem. So it is completed. Suppose if you see here, A derives AB dot, and if you expand, B derives A dot B. Again here, after that we are getting B. So we need to add B productions, AB and B derives dot B. So here only shift is there. By doing this or expanding this, we can write B derives B. So with this we can write, this is completed. So here it is B derives AB, and so that means it is existed here itself, because B derives dot AB, it is moved to this state. So if anywhere B derives dot AB is there, that is moved to this state only. Suppose B derives dot B, it is moving to this state, sir. Because B derives dot B, it is moving to another state, that is this one. So here, by expanding this, we can write B derives AB dot AB dot. Here there is no complexity or conflict. So we can say that the given grammar is SLR1 grammar. The given grammar is SLR1 grammar. The given grammar is SLR1 grammar. Sir, I clearly telling, if any one common symbol is there with reduce, if any common symbol is there, that is the conflict. Here, follow of reduce production contains the terminal of shift action. So then we can say that that is the SLR1. That is not the SLR1 grammar. That is not the SLR1 grammar. So, yes, sir. So now we will check previously asked 2 marks questions, sir. Which of the following is SLR1 grammar? Which of the following is SLR1 grammar? Which of the following is SLR1 grammar? S derives dot S and S derives dot SA, S derives dot B, sorry sir, dot B, SB, and S derives epsilon dot sir. Okay, right. This is the option A, sir. Next, option B. S derives capital A, small b. S derives capital B, small b, capital B, small a. And A derives epsilon, B derives epsilon. And option C. S derives dot A, B, and A derives A derives epsilon. Sir. Sorry, sir. Dots are not given. I have written. Okay. And option D is none of the above. So which of the following is SLR1 grammar? Suppose if we check S dash derives dot S. And S derives dot A. And here also S only. So that's why S is producing. Here also S only. That is. Sir, if you see here, this is the reduce action. And these two are the shift actions. So we know that if any item, LR0 item, having shift and reduce, then we need to check the follow of S. Contains the shift action symbols. Then we can say that that is not the SLR1 grammar. Suppose if you see here, S is the start symbol. So follow of S is equals to it contains dollar. And if you see here, after S there is a terminal. And if you see here, after there is a terminal. So after that particular non-terminal, if there is a terminal that comes in, fall off that non-terminal. So A, B. And A is the shift symbol here, and B is the shift symbol here. And fall off S contains A and B. Not required, sir. A and B both are not required. At least one if it contains. That is not an SLR1. That is not an SLR1. So this is not a SLR1 grammar. So that is not the SLR1 grammar. And next, coming to here, S dash derives S dot S. And S derives dot A. And S derives dot B. And A is deriving epsilon. B is deriving epsilon. If you see here, this is go to, this is go to, this is go to, because all are non-terminals. Because all are non-terminals. If you see these two, reduce, because these are ended. These two are ended in the same item I naught. In the same item I naught. So there is a RR conflict is there. There is a RR conflict is there. Suppose if there is a RR conflict, we don't say that is not an SLR1. Along with this condition, we need to check one more condition, that is follow of A equivalent and follow of B. Follow of A and follow of B equivalent to pi. So we say that not an SLR1. We say that not an S. Please don't confuse it. So what I'm saying is follow of A intersection follow of B equivalent to pi. Equivalent to pi. So that is SLR1 grammar. That is SLR1 grammar, because no common elements existed. Suppose not equivalent to pi. That means some common element existed. Not an SLR1. Not an SLR1. If it is equivalent to pi, that is SLR1 pass. That is SLR1 grammar. So otherwise that is not an SLR1. So now we need to check fall of A and fall of B. So suppose if you see here, what is fall of A? Small a. Suppose if you see here, fall of A, B. That means fall of A is equal to A comma B. Suppose if you see here, fall of B, small b. Fall of A, small a. So that is A comma B. So A comma B is existed in fall of A as well as fall of B. So this is also not an SLR1 grammar. This is also not an SLR1 grammar, because the common elements are existed in fall of A and fall of B. Suppose if any item having reduce conflict and the fall of A and fall of B. A and B means here the left hand side non-terminals. Here the left hand side non-terminals having the same symbol. Then we can say that that is not the SLR1 grammar. So second one is also not an SLR1 grammar. So we are having two more options. Another option is yes sir. S dash derives dot S, and S is deriving this one, and S is deriving this one. So not producing these two, Okay, sorry. I'll write S derives A, B, and A derives A, and A derives epsilon, sir. This is the grammar. From this grammar, I have taken I naught. Here, this is go to, this is shift. So no problem. So from this, if I expand, S derives small a dot capital A B. And here A is deriving. A and A is deriving epsilon dot. Here it is go to, here it is go to. So no problem. Next, if you expand it, so what we will get? S derives A dot B. Sorry, A dot B. So it is shift action. After B, there is no. After B, there is no symbol. So, and this is also A. This is also A. So we need to add this one also. A derives A dot A. Suppose if you see here, after that, this is also terminal only, sir. After this is also terminal only. All right, clearly, sir. I take this way. S is deriving A dot B, and A is deriving A dot A. So because it is A and it is also A. So from particular state, if I get a same symbol, I need to move to the same. So it is accepted, no issue. So again, it is S derives A B dot. It is A derives A dot. So it is accepted. So no shift reduce and no reduce. If there is no shift reduce, there is no reduce. So no need to check other conditions. So the given grammar is SLR1 grammar. So option C is the SLR1 grammar, sir. Option C is the SLR1 grammar. So from the given example, option C is the SLR1 grammar, sir. Right. So if you take any LR0 grammar, so it is already SLR1 grammar. It is already SLR1 grammar. And if any grammar is said to be SLR1 grammar, that should be the unambiguous grammar. So why I am writing this one is to specify the powers again. So SLR1 grammar accepts more grammars. SLR1 grammar accepts more grammars than LR0 grammar or LR0 parsing algorithm. SLR1 parsing algorithm accepts more grammars. Every SLR1 parser is not an LR0 grammar. Every SLR1 grammar is not an LR0 grammar. But every LR0 grammar is an SLR1 grammar. So along with the LR0 grammars, SLR1 having some other grammars or accepting some other grammars. So that's why we can say that SLR1 is more powerful than LR0 parsing algorithm. SLR1 is more powerful than LR0 parsing algorithm. Sir, is there any drawback in SLR1? Yes, there is a drawback. Sir, what are the drawbacks in SLR1 grammar? Because SLR1 grammar is less powerful than CLR1 grammar. It is less powerful than CLR1 grammar. And compare it to CLR1 grammar or CLR1 parsing table. SLR1 parsing table contains more reduced actions, So that is the drawback of SLR1 parsing algorithm. SLR1 parsing table contains more reduced actions, Suppose if you see LR0, SLR1, CLR1. So coming to here, reduce actions more than SLR, and here less, compare it to this one. But here these are more and compare it to CLR. So that's why I can say that LR0 parsing algorithm is less powerful than SLR1 parsing algorithm. And here SLR1 parsing algorithm is less powerful than CLR1 parsing algorithm, because the reduced actions are more here compared to SLR1. Reduced actions are more here compared to CLR1. In the same manner, it accepts less number of grammars, and it accepts less number of grammars compared to CLR1. So it is less than SLR1 and it is less than CLR1. That's why we can say that the LR0 is less powerful than SLR1 and SLR1 is less powerful than CLR1. So how we are overcoming these problems in CLR1, we'll explain in the next class itself. So first and follow, it is mandatory for constructing CLR1 and LALR1 parsing table also. So please practice how to construct the LR0 items DFA and how to construct the first and follow with the given formulas. With knowing those concepts only, we can construct the CLR1 set. In CLR1, we construct LR1 items, not an LR0 items. I will explain you in the next class what is the difference between LR0 items DFA and LR1 items DFA. So from that, we can construct the CLR1 and we can check the given grammar is CLR1 grammar or not like, and same time we can check the LALR1 grammar or not like. So we can construct the LALR parsing algorithm also and LALR parsing table also in the next classes. Thank you, sir.